should have. 35. Says we want to find the area between negative 1.96 and positive 1.96. And the reason I'm doing this one is because these numbers, negative 1.96 and positive 1.96, very important for the rest of the year. All right? And the others, the 2.33 and the 1.28, very important for the rest of the year. We're going to use them over and over and over and over again. Okay? And if you look at your table that I gave you, and here pretty soon we're going to have to use the tables because there's no way to do it on the calculator for some of the stuff that we're going to get to. If you look at the table I gave you down here at the bottom, guess what numbers you see? All those ones I just said. All right? So when we're looking at this, when we're going on our normal curve, zeros in the middle, 1, 2, 3 on that side, 1, 2, 3 on that side, standard deviations on each side. When we're going from 1.96, negative 1.96, which is somewhere about right in here, to 1.96, which is somewhere about right in here, we're looking for that area. This is, again, you need to be able to draw these graphs on the test. When we take a test over this, I'm going to make you draw the graphs. It's going to say draw the graph. If you don't draw the graph, you're going to lose a couple of points on that problem. So you need to be able to draw the graphs just like that. We're almost, if we're at negative 1.96, we're almost to what? 2. So if I look at this and, that's a horrible draw, but if I look at this and I go from 2 to positive 2, first of all, does anybody remember on our empirical rule, what should be between 1 and negative 1? How much, what percentage? 68%. What should be between each of the, or on each side here? 13 and a half, I think it is, right? 13 and a half, 13 and a half, 13 and a half plus 13 and a half is what, 27? So 27 total there. 27 plus 68. What's that come out to be? 75. Guess what should be between those two when we look at the, should be, so it should be, your answer should be like 0.95, something, something. Might end up with like a 1 or a 2 on the end. Brian, if you don't put that away, I'm going to treat like I said there. All right. He's got those games on there. So, negative 1.96 to 1.96, important, because that's about where 95% of the data falls. All right? If 95% of the data falls between those two, how much is on each end out here? 2.5 on each end. All right? So those numbers very important. We're going to use them a lot for the rest of the year. If you look at 36, 36 said between negative 2.33 and positive 2.33. What answer did anybody get for that one?
98.98.
Yeah. Those are important again because it sort of comes out exact. It's like 98% or real close to 98%. So if I'm looking at that on my little graph, if I'm from here to here and it's 98% in here, what percent's out here at this tail? 1%. How about the other tail? That's why that one's important, all right? Because you're saying, all right, we want 1% here, 1% out here. $37. On 37. Somebody help me out on 37 so I don't have to try to look back at the numbers. And those zeros in there. What'd they say?
To the left of negative 1.28.
1, 2, 3, 1, 2, 3. Negative 1.28 would fall somewhere like in here.
And to the left of that, and then to the right of positive 1.28.
Thank you. So this time we're looking for those two. No way, easy way on your calculator to do it, but it's not as hard as doing something twice. Anybody get one side? I think for one side on this one I got 0.1003. Does that seem about right? So that was for this side. Well, if I'm at negative 1.28 here, what's it going to be for the area to the right of positive 1.28 on that other side? Same thing. So really all you're doing is finding one and doubling it. All right? So we just times that by 2 and it comes out to be like 0.2006, something around there.
Yeah.
And 38. What numbers did they say on 38?
Negative 1.96.
1, 2, 3. Can't count today. So we're going from somewhere about in here and somewhere 1.96, somewhere about in there. We want this end, this end. Didn't we just do that? Oh no, we did the middle part, didn't we?
Yeah.
What was that middle part? Oh no, we didn't do the middle part, did we? Not for this one.
Yeah, it was 35. It was 95%.
Oh, it was 95%, so we did do it right at the beginning. Well, if that's 95%, how much is left for each of these ends? 2.5% here, 2.5% there. Now then your answer for the area for those two should be point, what is it? 0.05. So different ways you could find them. We did, this one I just wanted to show you because you already actually did that problem in number 35. But you found this middle area, well then the outside area is just going to be 1 minus that.
Probably why I didn't give it to us.
No, but I should have gave it to you so that you could see, hey, that's how it works. All right, on 40. You guys gonna have to help me out on 40, so I don't have to look back at my thing. 40. First thing we got to do is we got to make a frequency distribution chart. Should we do the tallies? Should I go through them all, or do you guys have somebody have them so that we don't have to do it? We'll do it. First thing we got to do is we got to find the class width. Does everybody remember how to do that?
Range over classes.
All right, so it's high minus low divided by the number of classes, which this time is 7. Looking through that list on there, what's the highest one?
60.
Does everybody agree with 65?
Yeah.
What's the lowest one?
25.
25. Making sure you're watching this, unless you're sleeping already. Is it just the row or something? Is that what it is?
It's gotta be. There's the tree of the last
I
time.
know.
Yeah, I know. I was worried, at least we're going back the other way now. I was worried that it was going to seep to more. We're getting less, so maybe that's a good thing.
I don't know, there's still time to go slides.
That might be.
I thought no one would know.
Divided by 7.
So does that mean I need to go?
It's like 5 points.
No, I don't want you to.
Oh.
No, I'm saying it's good.
I didn't know if you were just like stereotyping our whole row or something.
No,
Jackie, go take a nap.
I'm saying it's a good thing that we're decreasing the number instead of
Right.
increasing the number.
I tried
It's
to
like
get box top,
5.7.
but I'm surprised that I didn't get back to
Those two.
It's about to get that back.
What have I said?
It ain't going down any lower.
That's why you just don't go to class.
Daniel already made the decision when we walked in here that he was
Just don't
going
go
to
to
sleep.
class.
Somebody help me out. 65 minus 25 divided by 7 is what?
5.7.
5.7. You got to remember, we round that up, so it's going to be rounded up to what?
6.
So that's our class width, is 6. We start with the lowest. What was the lowest number? 25. Remember, you make the low limits first. We want 7 classes, so we just add 6 to that each time. 25, 31, 37, 43, 49, 1, 2, 3, 4, 5, 55, 61. What do I put here?
30.
Just look at this one, go down 1. 36, 42,
48.
how do I get this?
Add 6.
Add 6 to that last one there, so 66. Does that look like what some of you have?
Yeah.
So that maybe I don't have to do the tallies? What was the frequency for this first one? Or should we go through the tallies?
Should probably go through
All right, somebody read me the list.
40, 45, 54, 41, 43, 31, 47, 30, 33, 37, 48, 57, 52, 45, 38, 65, 25, 39, 53, 51, 58, 52, 40, 46, 44, 48, 61, 47, 49, and then 57.
Is that all of them?
Yeah.
4, 10,
No,
19, 20, 25, 30. Was there 30 of them?
Yeah, probably.
Yeah, there
Yeah,
is.
30 people.
So 2, 2, 6, 9, 6, 3, and 2. Next thing they ask us to do, make a histogram. When you're making your histogram, some of you, again, on the exam, didn't look too good. Got to make sure that you do some of this stuff right. First thing we probably want to do, we could put all these numbers on our histogram if we wanted. Probably don't want to. Find the midpoint. What's the midpoint of this one? Add them together and divide by 2. 25 plus 30, divide by 2.
27.5.
So 27.5, that's going to be our first number here. Each one, as you go up, to get the next midpoint, all you got to do is add the class width. So what's this next one going to be?
33.5.
Then what?
39.5. 45.5.
If I mess up, somebody tell me. Everybody agree with all those?
Sure.
The other thing that a lot of you aren't doing that you have to do, that I took off points for on the test, got to have a label down here. Read the problem. What did it say? What are we talking about?
Milk consumption?
So, I think it was ounces, right?
Yep.
Ounces of milk.
What's the difference between fluid ounces and ounces?
Yeah, it should be my fault. Since it's milk, it should be fluid.
That's a lot of milk.
So fluid ounces, going up the side, we want our frequency.
You just got strong bones.
That's not really, for a week, 27 ounces. Maybe, that might be a lot for you guys.
I'm lactose.
Did you drink a gallon?
My-
It's fun for you.
I probably drink,
How many are in a gallon?
in a gallon, 128.
28.
I probably drink
Well, that's slight.
200 ounces a week.
We get
Done.
3 gallons of
I have-
every week we go to the store.
I have a son, he probably drinks
I don't even have 3
5
gallons in
times that.
my fridge right now.
Right, so
We have one.
We
right,
all-
right now, if you go to my refrigerator at our house, we probably have 4 gallons of milk in the top refrigerator and probably 6 in the basement refrigerator.
We have like 2 at
What do
most.
you need that much milk for?
I'm not like
Cause
that.
it-
I'm
it
not the
don't
guy
expire?
who's like
Like, you
percent
guys
fat.
No, we drink it.
Either.
it
I
gets
just
cold.
like.
It's got like a 2-week.
Oh, we
We
got-
usually
Right.
run out.
They
we
might
run
drink
out.
it.
That's so good, 'cause we drink 2%.
You're like the type of guy who's like,
I
well,
can't-
oh,
I
the
can't
milk's about to
drink
get expired, drink it all.
But I can drink.
Frequency, we need our frequency side to go from 2 to 9, so I'm just gonna go by
I
1.
could see Ebersole double fisting the milk.
It really makes me like sick.
He gets a strainer out when the milk gets a
I
little
don't
chunky.
understand.
Eggnog makes it so much worse.
My wife gets on me all the time because she says it's not good, she reads that it's not good for old people to drink milk. I guess there's something that.
Mr. Boggs says we probably shouldn't drink milk.
She says it's not good for old
Really?
people to drink milk.
It's not true.
Yeah.
Maybe.
It doesn't, no, it doesn't go to the
Isn't it
bones.
supposed to
Bog-
strengthen your
Milk
bones?
comes from
Boggs
cows.
told us, once your bones fully grow, you don't need milk, it just goes in the fat.
But milk,
I love
that
that
kind of guy.
Milk head.
Strawberry milk? You guys don't remember any Boggs milk?
I like
strawberry.
That
Dude,
was
chocolate
right.
milk?
It's
The only
my
thing I
soul.
wouldn't come back.
I don't like.
That's what's gonna eat up my coffee.
Nothing's better than nice hot
Did
chocolate.
you guys It was so bad because I could still taste it. It was like one page.
I put ice in my white milk
And then at the end we had like a laundry, like
But I can
illustrated
eat
hill.
cereal and I
And they were
They
all
never
different
made
ages.
these, like,
And
well,
I
they had, like,
can
cinnamon
drink
rolls, like,
Me and my Ella's and at the end,
But I never go to the
I know
doctor.
what
and they were all in
I
different
know I'm not
shapes.
lactose
Like they had
intolerant because I
like
can eat dairy.
Mercedes. I can like.
So maybe, I mean, we buy 2%, so maybe
No, they
it's
had
just
like
the
a
milk
scoop.
that we,
whole milk.
but.
So we,
Whole
now
milk over
that,
2%.
now that they're the same price, we were buying whole milk because my son was on a big milk kick and somebody told him that whole milk was better for you. And then somebody else said that he figured out that somebody else
Oh,
said
they do that with my
that
son.
it's not better for you. And
Oat milk
So-
costs a lot now.
but if you see my son,
A dog.
he looks like he's been, my oldest son, he looks like he's been on the roids or something because
Cause he's a dog.
He's been drinking that whole milk.
he was a little skinny kid, just like all my other kids. He was a little skinny and then all of a sudden now he's like,
Hit the gym.
he hit nothing. It's the gym's in my daggone basement. I can't do anything in my basement because we got free weights everywhere.
He's looking like you in your 20s, right?
Yeah. He's looking like me.
Me now. Thought you said.
She got a nasty. Alright, so this is what our histogram looks like. The next thing they asked us was, can we treat this as normal? Does it look like it's a normal setup?
Kind of, sort of, yeah.
So, I mean, if I did this, would it look sort of like the normal curve?
I mean, kind of, sort of.
Yeah. So it's pretty close. So, yes, we can treat it as normal. That was the next answer. Then B said find the mean and the standard deviation. What are we going to have to do to find the mean and the standard deviation? Nobody remembers?
It was a while ago.
calculator.
Put it in the calculator. You're going to have to put it in a list. Put it in the calculator, let the calculator do it. Now, we could do it by extending our, do we want to extend this chart on out to do it that long way?
No.
That everybody, I'm sure, Alexa probably remembers how to do it the long way, right? Then none of you might have did it once when I forced you to do it because I didn't tell you how to use a calculator, and then after that, nobody did it.
I didn't even do that because I had the notes that day. So I just like skipped to the calculator steps.
Oh, yeah, that's right. I do remember I screwed up and put it on there, didn't I? So, we find the mean standard deviation. When I did it, the mean of our test was 45.87, and the standard deviation was 9.46. So again, if I was going to draw this, and I'm going to draw it over here on the side, trying to show you, if this was on the next test, the next thing I would ask you to do is this. I'd want to see the normal curve drawn in relationship to those numbers. All right? What's gonna go right here in the middle?
45.87.
45.87, the mean. Now, if we were gonna do the standard normal curve, that's where we put 0 in there. But if we want the raw scores, this is what we put. And then we go 1, 2, 3 on that side, 1, 2, 3 on this side. What do you have to do to find what each of those are?
Add a deviation.
Add
9.6.
9.6 going out this way, or subtract 9.6 going down this way. All right, and I'm not gonna do all that. You can put those numbers in. On the test, you need to put them in. But that's the picture I'd want you to draw. What did you notice about their mean in relationship to our mean? I think their mean was, let's see, looking at it. They said the mean was 48.7. 48.7. So what's true about their mean in relationship to ours?
It's different.
It's different. How?
It's about 3 off.
Which way?
To the right.
It's 3
To the
higher, right?
Okay.
Theirs was about 48, ours was about 45, 46. So
And
2 or
higher.
3 higher theirs was.
I knew I was
Uh,
something.
But then their standard deviation was 8.6. So what would that tell you about their graph if I was going to look at it like that? If the standard deviation is 8.6, what's that doing to the graph? All right, it's not going to be as spread out. Ours is going to be a little more spread out. Theirs is going to be less spread out. Other questions on the homework?
Paycheck and deposit.
Today's tuning only needs 76 catches to get his bonus. The Giants wide receiver only needs 76 more catches this week to get his bonus.
Oh, he'll get it.
76.
I mean, 76.
Yeah, just get one game.
He only needs 76 more catches.
Dude, Daniel Dimes. He's gotta do it. Those 100 passes. 78 of them.
I'm being honest. I'm not
Let's go, bro.
Hey, this week, Today's tuning
Red
needs
88
76
all the way
catches
down
and
to
$75,000 bonus.
All game.
Yeah.
76 catches. Did you?
That's like 5 breasts right there you just sliced.
But it was worth it because I was trying to help Jackie. On that homework, don't do it right now. If you put your name on it, you turn it into the thing before you walk out. If you did all of it, I'll give you extra credit.
Shoot, I don't get extra
Put
credit.
your name, no, put your name on it. I'm saying don't turn it in right now. Because I don't want you up. What we're going to cover, and we're going to be able to go over this very, very quickly. Because for some stupid reason, that day back from break, that first day, I just wasn't with it because I screwed up in a couple of my classes. This one was one of them. Last time we were finding areas, and I kept mentioning probabilities because they're the same. This section, we're finding the probabilities, so we're doing the same thing, just finding probabilities. Okay? So these notes, not very long. The assignment, we'll probably get it done, or we'll probably get to it here in about 15, 20 minutes maybe. Just finding probabilities using this. Same thing as we were doing. Area, probability, same thing for that normal curve.
I figured.
You see it says skip that, because we're going to skip that. I'm trying to think. This is the one. If we're doing raw scores, well, it doesn't matter. Raw or using z-scores. This is how you punch it into your calculator. I couldn't remember how to do it last time. I didn't have it on there. I thought I did, but apparently we got to put this one. This is the same thing. We'll find the area between two things, or the area from this one down or this one up, and we just do that. Remember, on the low limit or the high limit, if you don't have a low limit or a high limit, put in something like negative 1,000 or positive 1,000. I think I even got down to like putting in 100 because I got tired of pushing the 0 button, and it still gives you the same answer.
Sometimes I forget to put in the negative, but.
Yeah, I did that, and it kept saying error. I'm like, what is wrong? And then that sucks, cause then I remember that I go back and push all these buttons. Thinking, why, I didn't do anything wrong, and it took me forever to get my eyes bad. Figure out that I left the negative off of the thousands. That's right. And I punch it in again. So you can use this with raw scores or z-scores, either one work. You do have to remember, this is probably something I didn't specify enough last time. If you're using z-scores, what's the mean? 0. If it's a z-score. What's the standard deviation if you're using z-scores? 1. So make sure you know that. That's only for z-scores, for the standard normal. If we're just doing the normal, then you can just put in the raw scores and the calculator will do it for you. Gauge on your calculator, is it different than, well, it's a little different than what this is, because it's just got a list and you just put in the 3 things, or 4 things, can't count.
I always wonder if I could just like stand up in the middle of class so I
You
can
should do
not
it,
fall asleep.
Yeah, do you remember,
I don't mind if you just get
sophomore year, you used to tell us, if you think you're gonna fall asleep, you gotta stand up.
Who said that?
You.
You said it just like that, I remember.
He slept at me for sleeping on the wall.
Oh, yeah.
I love being this man. Keep his mouth shut.
No, you didn't.
He wasn't on his phone.
You never let me sleep.
If a random variable is normally distributed, you can find the probability that x will fall in a given interval by calculating the area. All this is saying is that the area and the area and the probability are the exact same.
For what?
Yes. Sure.
Sure.
So same thing we were finding before, nothing hard about it. I'm going to skip over a whole bunch of this. It's exact same stuff. If you wanted to convert, remember that formula, because on the next test, I will ask you to convert raw scores to z-scores. We've written that down a few times, but if you're not sure about it, you might want to have it somewhere. So some of the problems on the next test will be change this score into a z-score. Now some of you, you might have taken the ACT or SAT or stuff like the ASVAB. I know that was your sophomore year, I think. But some of those standardized tests. And they usually give some standard score, like a z-score, right? You should be able to put in there and change it back to what your raw score was if you have that. So for like the end of course test that you had to take for some of your classes, you should be able to put it in there and change it back. Now the bad thing with the end of course test, there's no sense.
So if I do really bad though throughout school, and they're like, Brendan's score should have been down here, well, he scored up here. What's wrong with that? Do they start moving me down?
No, they're probably not, all right? But they don't. But it's not consistent like across this curve here, where if I just took 100 people and I stuck them into this normal curve and say, okay, 2% ought to fail, 2% ought to get A's, and 68% ought to get C's, and so on, like we talked about. They start off that way, then they sort of shift some of it. They might shift this section over a little bit to make the scores a little better or a little, it's stupid. It just doesn't make sense. This is about changing it. We're not going to change it, so I'm not worried about that. Survey indicates people sell your phones an average of 1.5 years. I don't feel like doing this. So 1.5, that's this, that's that. If we were going to do this and we wanted to find the probability that you have your phone and you keep it for less than a year, Then in our calculators, we're gonna plug in negative 1,000 or 10,000 or whatever. Our upper limit is, I think that's supposed to, is just gonna be 1. Our mean is 1.5 and our standard deviation is 0.25. We type that into our calculator and it's gonna tell us this area. 0.02. So if it's 0.02, that means about what percentage of all people keep their phone a year or less? About 2%. See, Ebersole screws all this up. He throws the curve off because he keeps his like 15 years.
The battery lasts that long?
Sometimes. I had one that caught on fire when I was in here one day.
What? Like actual like.
It ain't good for you to.
It started getting hot and I thought, man, it's getting hot. And I put it on the ground and I could see smoke rolling off of it and stuff. So I had to,
Them fumes.
How old was that phone?
yeah, it's not.
I'm
It's not
still a flip phone.
The average speed of a vehicle traveling a stretch of highway is 67 miles per hour with a standard deviation of 3.5 miles per hour. If a vehicle is picked at random, what's the probability it is violating the 70 mile per hour speed? Anybody know why we went to the 70 mile per hour speed? Because of this right here. Cops sat out there, or somebody sat out there and they figured out, hey, you know what, most people aren't going 60 anyway. So, and it's not hurting, there's not more crashes than there was the previous year, so why not raise the speed limit? Cars are safer and stuff. So they did something like this and figured out that what the good mile per hour was. Anybody, where did 55, you guys are too young now because nobody remembers it, but 55 was the big thing when I was growing up. Where did that come from?
On highway.
Same place. They started doing surveys and they figured out 55 was
It's not Flintstone cars anymore.
where you could be safe and still go, you know, what was the top speed that was still sort of safe? 55. Because before that, anybody know what the speed limit was before that?
45.
30. 7.
No speed limit.
There was no speed limit.
Oh, that's
A
right.
lot of places, it was just random, all right? So it was just random everywhere. You know, this town or this town decided, hey, I want this speed limit, and so on and so on. This state decided this. There wasn't anything set. It was just whatever.
Did they tell you if they just? Is that where like lead foot came from? Like, you knew somebody with lead foot because they were going 120 through your town?
Get your kids out the street.
I know that's where those signs came from.
I'm just saying, laws are not the speed limit, it's just a suggestion.
Yeah, if it was important, they would have put
Remember
it
that.
like a big red sign.
I will because I don't,
It's
I
like a
don't follow
stop
it.
sign.
Me and Riley will come visit you one of these days.
Does he want to sign?
I do 70
Right.
on 40.
What's that color?
The stop sign.
Oh, that.
Look,
It's big and
listen,
red, dude, like,
listen.
easy for
us to down.
Mason
Look,
literally told me that he
Yeah,
doesn't
sometimes
even,
I'm like,
he
I don't
doesn't
feel like
even
stopping.
pull anybody
And I'll just,
over
like,
on
slow
40
down,
unless they're doing
screw
over
back.
70. He's like, you could be doing 70
I've
and
never ran.
There goes Mason
Straight up
down.
30.
But if you do 71, I'll pull you over. And he literally told me that he doesn't
Me
pull
too,
anybody
yeah.
over in front of the school unless they're doing like over 35, even though it's 20.
He said he wants to pull people over in front of the school for going over 20 because
He told me he doesn't pull.
You should
any-
pull
he
over
doesn't
Caden
pull
for
people
driving.
over.
Guys, I drive the speed limit. Everybody gets
I went to,
mad.
you don't even know.
I drive like an
I
old
think
man.
he's just
and-
trying to get me to go over the speed
Hey.
limit so that he can.
And
Nah, dude,
because-
Tyler knew what happened
because-
last year, and he decided to put us right next to each other.
I know what happens if you watch 70 out here.
That's fun.
In the last 10 years, there's probably been 15 people killed on 70 on this stretch.
That's a lot of people.
Yeah, it's ridiculous.
There was that one like May where there was like
Yeah.
smoke and we could see all of it.
Yep. And
Well,
it ain't. It's not
sleep
because
while she's driving.
it's not because people are terrible drivers.
She does.
It's because they don't pay attention. And then the faster you're going, the less time you have to react. And especially on a road like 40,
I don't know, my brakes are pretty good.
with all these side roads.
My brakes are pretty good.
I'm driving 70 miles an hour down 40 and
So it does that same thing, it just stresses me
I
out
look
so
over
bad.
for some reason, and then all of a
I'm
sudden
good
somebody
driver.
pulls out.
Just because I go fast.
When I lived in
doesn't
El
mean I'm a bad
Dorado,
driver. Okay.
Build-
I probably
726,
shouldn't go fast.
726 and 40 where they cross, there was
Come off
like,
at any minute, but it's fine.
once every
She's
year there
testing
was somebody
fake
killed at
news.
that intersection because
So
people
is
flying down set, or
Like, my
down
car's
40,
literally a death trap.
and people on 726 pulling out
My
in front.
car's not a death trap, but everyone
It was,
thinks it is.
My
it was
car's a death
7:20
trap.
when I left my
Listen,
house.
I have a loose tie rod,
I got to
so,
school by 7:20.
I probably shouldn't be speeding, cause like.
And
You know what a tie
made
rod
it to
is.
class by 7:20.
That's not even that bad. She got
You know
camber.
what a tie rod is?
She got camber. It's not even that bad.
No, I don't know, but the
My
guys that put
360
on, the
caught
guys
me
that put on my new
71.
tires were like, you have a loose tie rod, so we can't align your tires. You probably should go get it fixed so your
was
tire
close.
doesn't like come off.
Aligning
I
tires.
got glad
On
it wasn't
this.
that close.
This is the part I do want to go over to make sure that you know how to do it. Sketching the graph. What's, if 67 is our mean, and this is our standard deviation, what goes right here?
67.
67.
Plus 3.5.
So what is that?
71.5.
70.5, next.
73, no, 74.
74, next.
Yeah.
77.5, going the other way.
Same thing.
No, an 8.
Subtract it.
63.5.
63.5, next one. 60, next one.
56.5.
Now,
bad.
even though we have it in raw scores, you should be able to, and this is going to be part of the next test also, tell me what's the probability that whatever score we're looking for falls in that range right there. 68%. All right? What's the probability that it falls in that range right there?
Like 13.
Other, farther out.
Like 2.
It's like 2.4.
I thought that was like
2.35. All right?
I just must
So
have
you
known.
should be able to figure out all that stuff easily from that. Guarantee there'll be questions like that on the next test.
So that's just, that's just.
Yeah. Yeah, it's not hard. You just gotta make sure you're adding standard deviations going one way or the other. Survey, we're not gonna go through this. This is, some shopping supermarkets actually do this. A shopper spends an average of 45 minutes in a store. So when somebody's in a store for like 65 minutes, guess what they start thinking?
They steal it.
Somebody's stealing something, all right? And shopping centers, Walmart, places like that, they know that. So
You're just bored and you go to Walmart.
as they're,
You have nothing to do.
yeah, you got no life. Those
Well,
are,
there's nothing to do
those are,
around
those are the same people who are
Oh,
stealing things.
We're just teenagers.
Yeah, until you reach like 100.
I actually-
No, you
It
can't
was
check
more
my
like-
pocket.
I accidentally stole
Like
once.
Gauge.
How do you
According
have
to
that?
How do you
the-
accidentally
So if it gets
No, I was like,
he
I
is
was like
5,
7,
it'd be okay.
and I got this like dog tag thing, and I don't know why, but I stuck it in my pocket, and I grabbed another one, so I technically did pay for one, but I got 2. I thought I lost it. I thought I put it somewhere.
I started to do that the other day. I was walking through Walmart and I didn't grab a basket, so had my
I
hands
got 2
full.
for 1.
And I had something that was small, and I started to stick it in my pocket, and I thought,
30 feet.
no, don't do that.
Yeah.
It was at that
Steals
Martian.
constantly
I
now.
totally blame on paint on it, it was out of hand.
No, so we're supposed
It
to
don't matter,
count,
'cause
we're supposed to
it's
like count down drawers at the end of the
That's
night.
what I'm
paying
And
for.
if we have
Just
customers in
paying
there, we're supposed to be like
Just
discreet
pull
about
out one
it.
dog
So I'm
tag.
getting in the safe and I'm pulling up like multiple
I shut down
stacks.
mine.
And I put it in my pocket,
By
but I'm
stealing
like,
one dog
you guys
tag.
probably thinking I'm stealing it. I swear to God I'm not. Like,
Just open it as loud as possible.
I bring a backpack.
Hey, I'm doing this.
I bring a backpack in there, stuff it full, and I'm like, here, open it.
On this one, to create this graph, again, just looking at this, this is kind of question I put on the test. 45 is gonna go right in the middle. Standard deviation's 12, so that'd be 57. If I do something wrong, somebody please tell me. 69, 81, down this way would be 33, 21, 9, is that right?
Yeah, sure.
They want to know between 24 and 54 minutes. So 24 would fall maybe somewhere around here. 54, somewhere about in here. We can, unless we grab our calculators out and do this and put this in as our low limit, this is our high limit, mean, standard deviation, so on and so on. we can't get exact, but we could get real close here. If this is our mean, I always like to mark it so I don't forget where it's at. What should be in this part right here? That part, 34%. What should be in this part from here to there? About 13.5, right? And then this part sticks out a little more than that, so it might be a little higher. It's not all the 13.5, might be about 6.5 or something's about half of it. This one's about half of it. Let's just leave it that way. You add those two together, that's about 47.5%. We're probably pretty close to that, and we could figure it out if we wanted. And, probably on the test, if I was doing this on the test, I wouldn't have put 24 and 54. I probably would have put something like, what's the between 21 and 45? So the distance or the probability from here to there. And then we could have just added those two together and got the answer. As long as you remember how to make the graph and remember that empirical rule. If we were close.
That makes it a lot more confusing.
That looks.
Why is that 73? That seems like an awful lot. Maybe I didn't have my picture drawn very well. The other thing, 200 shoppers. So if it was 73% and you have 200 shoppers, how could we find the number of shoppers who are going to stay in the store between 24 and 54 minutes? You just multiply it, right? So we just take that percentage that we got and we multiply it by how many shoppers? 200, and that's going to give us 146.66 shoppers. So when you're looking through Walmart and you see that 2/3 of a shopper, right, Jackie? See that 2/3 of a shopper?
It could just be the daily paper, 2/3 of their
Or
stuff.
are they missing a body part and they're missing their head?
It's
Pretty comfortable.
knees down.
I feel like it'd be pretty.
I feel like that's like 2/3 to people that have.
I feel like it'd be pretty hard to
And
steal
then
with
two-thirds,
it.
you know that one, because you're with me.
Plus half.
No,
You'd be short a little
sometimes
bit.
where I just go into like cash. Like,
How would you get around?
I go to the bank, so I'll just get like.
You just got stuck.
Because it's like $1 and then put it in.
Nah, there was a news article.
No.
Said
So much easier.
armless man, armless and legless man. Police say he's armed and on the run.
No, it's not.
There was a news article that said there was an armless and legless man that was armed and on the run.
Who made that noise?
He did.
Man out here.